Hello, today we're going to look at solving systems algebraically using the substitution method. So we're going to have two equations, right, a system, and the steps to doing the substitution method are as follows. Number one, we're going to solve one equation for one unknown. Then we're going to substitute this into the other equation. We're going to solve the resulting equation for the unknown variable. We're going to substitute this value into your result from step 1. And then we're going to check your values in both equations. Okay, so let's try out this one. 3x plus y equals 1 and 2y equals 3x minus 16. The first step, we're going to solve one of the equations for a variable. Doesn't matter which one, but I think it's fairly obvious that solving for y in either of the equations is easier. So we're going to solve for y in the first equation. So y equals 1 minus 3x. So then we're going to substitute this into the second equation. Everywhere I see y, I'm going to plug in 1 minus 3x. So I get 2 times 1 minus 3x equals 3x minus 16. The next step is to solve this equation for my unknown, which is x. So use some algebra, solve it out, pause it for a second, and let's see if you get the right answer. Okay, so if you do it out, you should get x is 2. Next, we're going to sub it back into the equation from 1. Y equals 1 minus 3 times 2, which is negative 5. Lastly, we're going to check. Is 3 times 2 plus negative 5 equal to 1? Yes. Is 2 times negative 5 equal to 3 times 2 minus 16? Yes. So we know that we have it right. So let's try another one. 3a plus 3b equals negative 1, and 5a plus 6b equals negative 1. So again, I'm going to pick an equation and pick a variable and solve for it. So again, I'm going to choose the first equation, and I'm going to solve for the variable a. So a is negative 1/3 minus b. I'm going to substitute this into the second equation, and I get 5 times negative 1/3 minus b plus 6b equals negative 1. And then we're going to solve this one for b. So again, I suggest pausing it, solving it, and then unpausing it to make sure you get the same answer. So if you solve it, you should get that b is 2/3. Then we substitute this back into the equation from step 1. A is negative 1/3 minus 2/3, which is negative 1. Then we check. Is 3 times negative 1 plus 3 times 2/3 negative 1? Yes. And is 5 times negative 1 plus 6 times 2/3 equal to negative 1? Yes. So again, I know that I'm right. I don't have to worry about it later on. That is the beauty of checking your answers. So we're going to look at the last one using this method, which is 2p minus 4q equals 7 and 4p equals 8q plus 14. I'm going to solve the second equation for p because all I have to do is divide everything by 4. So p is 2q plus 7 over 2 if I simplify it. I'm going to substitute this into the first equation. So 2 times 2q plus 7 over 2 minus 4q equals 7. And now I'm going to solve it. When I solve it, I get the following. 0 equals 0. It can happen where both variables, where the variables cancel out. So there's no q's left. And what I'm left with in this case is a true statement. 0 equals 0. That is true no matter what p is, no matter what q is. 0 is 0. When this happens, it means that our two equations were actually the same, and the system is dependent. So if I go back and look at 2p minus 4q equals 7 and 4p equals 8q plus 14, if I put them both into standard form, so with the p's and q's on one side, the constants on the other, or put everything equal to 0, I will see that they are multiples of each other. So if I take the first equation, multiply everything by 2, going to be the exact same equation as the second one. So again, that just means our equations are the same, which means our lines are the same, and the system is dependent. Okay. So I want you to go and watch the video using the addition method also, and try them out, see which one you like better, and you can just stick with one of the methods, either substitution or addition. It doesn't matter which one. I'm never going to tell you use a particular one. Okay, so try them out and let me know if you have any questions.